Welcome to session 13 of the KYTC Structure Inspection Level 1 series here on YouTube. This one is on bridge rail and guardrail connectors in relation to bridges. Some of the things we're going to talk about and try to go over in this lesson are just understanding the different types of bridge rail. So that goes all the way from metal guardrail systems to concrete barrier wall type systems. Also understand the different bridge rail connectors, so how we're connecting to the rail on the bridge, whether that's concrete or guardrail, and also just understand the importance of proper installation. The first one we're going to talk about is the railing system type 2. This is a kind that we've been using for a while, but as you can see in these two pictures, it is a strong beam guardrail system that's got the box tube stiffener going in between the rail and the post. And these are just what we've been using for a long time, continuing to have them. If you look here at SEPIA 51, you can see how it's to be installed. Here's that steel tube blockout system. It's our standard guardrail post, how it's bolted onto the bridge, whether these are threaded couplers or drilled and epoxied in. One of the things I really want to draw your attention to here is this detail over here where it talks about allow sliding between the tube and the channel when tightening bolts in these slotted holes. These are designed to be able to account for any expansion and contraction in the bridge. That way you don't get any buckling in this tubing system. So make sure that the contractor does that, and the tube has the ability to move back and forth with the structure itself. So the next one we're going to look at is the side-mounted MGS system. I will say the first time I saw this, I didn't believe it would even hold a car. But we've been putting more of them in, and I've started doing a little more research. It is affected. It is part of the Midwest guardrail system, and this one is side mounted. We'll see these a lot on our bridges where we're doing side-by-side box beams with a 5-inch overlay. You can see here they've got a little channel that they sit in on the side of the bridge, and there's no stiffened beam behind these like is in the rail system type 2. So let's look at the SEPIA 54. Hope to have these in the standard drawings pretty soon. Let's look specifically at the construction notes. Right here in these notes, you can see this traffic railing must be anchored by a minimum of 25 feet of guardrail on each corner. So for your project, you're going to have at least 100 foot of guardrail, 25 foot on each corner. This is to help anchor the railing system on the bridge. Now, these threaded rods may be cast into the beam or slab, or they could be drilled and epoxy grouted. Most of these are actually put in. You'll get the bottom one in the beam when it's cast at the precaster, and then the contractor will have to locate the one in the slab. These have got to be laid out right to make sure that you get the right height of your guardrail system. But down here in the general notes, as you can see, this railing meets the MASH TL3 criteria, which for speeds greater than 45 mile an hour. One of the things that I've noticed is it will deflect approximately 4 to 4.5 feet as it redirects a vehicle back. Typically, these are on some of our lower volume roads that we're putting these on. It's not high speed routes, not wide bridges, but note it will deflect 4 to 4.5 feet. So let's go back to the SEPIA. Now let's look up here where you can see it's circled in blue. Let's zoom in on that. Here you'll notice the splices. This splice right here is mid-span, just as by the Midwest guardrail system. Then you move into this 9-inch gap to the first post. There has been some issues of getting that 9-inch with the wings, depending on how they're angled based on the stream. These posts are spaced at 3 foot 1.5 inches. And then with your first splice connection, whether you're using a 25-foot rail or a 12.5-foot rail, is at the post. Unlike the Midwest guardrail system where it's mid-span, it's spliced at the post itself. So let's go down and look where it's attached to the bridge. So here you've got the post coming up and the guardrail is attached to the beam. Make sure that is attached correctly. I've seen several jobs to where that double nut is loose and I can loosen them by hand because they're using the wrong bolt. That is supposed to be a 5/16 inch diameter hex bolt with a nut. I've seen some where they just didn't have enough threads to be able to get back into there. So make sure you've got your plates and the double nut as designed. Also down here where we got our embedded anchors. You can see this bottom one is embedded at the precaster if these are on box beams. The top one's by the contractor. This could also be done with a slab bridge to where these are cast by the contractor themselves when they're forming for the slab. So our railing system type T63-1, this is a top mounted system with bolts that go all the way through the deck. These are ones where we have to have an overhang. So if you've got a box beam system that is just going to the edge of the beam, you will not be able to do this. As you can see, here's one on a precast I-beam. You can see the bolts sticking through. This is TL3 as well. It's used for speeds 50 mile an hour and greater. It is designed with, just like the side mounted, to deflect 4 to 4.5 foot before it redirects the vehicle. And the rail cannot be installed on top of or behind curbs that project above or bridges with more than 5 inches of movement. I would say if you've got a bridge with more than 5 inch of movement, you're going to have a concrete barrier because that's a pretty long bridge. So let's look at this detail. It's very similar to the side mounted. We're going to look at the connections at the slab. We're going to look at the connection to the beam into the slab itself, and then also an alternate anchorage. So let's go here to where it's talking about the elevation, and right here at the rail. As you can see, this one is spliced mid-span again, same 9 inch, which you're not going to have as much issue here unless you have a wing that sticks up higher. So it's something you might have to look for in your plans. If that 9 inch first post is going to land right on top of our wing and our wing is 6 inch higher than the deck, we're going to have issues. So make sure you look into that before you start construction of that area. And then our splice is right on a post, whether that's for a 25-foot rail or a 2.5-foot rail. So let's look to the section here where it connects to the bridge. As you can see here, these are formed holes and then use heavy hex head anchors. So the contractor, as they're forming this overhang, is going to have to use some PVC or something here to form these holes. Make sure those are laid out correctly. Check them. They need to be 6 inch center to center, or these are 4 inch center to center. And if you look here, there's 6 inch from the traffic view. Make sure we've got our required clearances for the plate. Double check these. A tape measure is your best friend. Before they pour concrete, go check those. Up here, the same thing. Make sure that's bolted correctly with the right bolt and the right plate. And then make sure everything's good so we get our proper height of 31 inches. Here is that alternate anchorage system. This is more if you're going to get into a slab bridge. Not often do we have concrete that's greater than 11 inches thick. So really the only time you're going to see this is on a slab bridge with a 17 inch deck or greater. But note that is a possibility if you're doing one of those. Here's a picture, a good picture kind of zooming in of this one. These bolts are through. You've got the plate on the bottom and they're tightened down. Make sure these are tightened as per the standard drawing specifies. You don't want to be able to reach down there and get them, loosen them, because you want to be able to make sure it redirects any errant vehicles. All right, let's move into our railing system with concrete barrier. Our first is a 40 inch single slope. You will note this is different than what we've been doing with the rail system type 3. Our rail system type 3 was a jersey barrier shape. We have switched with the MASH system to a single slope wall. So at the standard drawing, let's look at the general notes first. This is a TL4 rated wall if you use a TL3 rated transition, which is our type TL3 THRIE beam. If you go down to a TL2 THRIE beam, you can only be used if it's 45 mile or less. Also down here, note that the straight reinforcement is to be number 4 bars, and it's lapped 1 foot 11 inch when necessary, and they are epoxy. So it spells it out in the standard what to do. Make sure the contractor is adhering to that, and you're checking that. So let's go down here and look at the barrier section. As you can see, this gives the detail for how the steel is going to go in. As I said, these are number 4 rebar, epoxy coated rebar. And then down here, note 1 calls it a mandatory roughened construction joint. That's right here. So the contractor is going to place all the deck steel here, place these bars in with the deck, and then pour the deck. Once it gets cured and they start pulling the wall covering back, they'll come in and start tying this steel. But make sure that's roughened. It's not typically going to get finished because of the steel and the way the finishers have to work around it. but make sure they've done something to roughen that up. We want to get a good bond between the barrier wall and the concrete deck. All right, so here's another, just at the 40 inch. Let's look at how the bolt holes are in. So here are the location, the spacing of all of them, and you note the form or core holes and recesses. Typically, if a contractor can form it correctly, they'll put the PVC through here to give you the holes, but more often than not, those aren't put in straight, and the guardrail contractor is going to have to come in and core those. So make sure you discuss that with your contractor prior to. Check those if they are forming them. Check them to make sure they're tight and stiff and not going to move when pouring concrete in there, because those have got to be spot on to be able to bolt the THRIE beam transition on it. Make sure you've got your tape measure out, checking the spacing of these holes to make sure they're correct before they start pouring concrete. All right, the 36-inch single slope is kind of used where we got sight distance as an issue. It more than likely is going to have a steel handrail on top to give you your extra height, but very similar to the 40-inch, just some different dimensions. So as you can see here, these dimensions of your height are different, which impacts the width at the top and the width at the base. Every steel detail and everything else is the same, minus just the dimensions. All right, let's move into our guardrail transitions, or our bridge connectors. You'll notice now we've switched to a THRIE beam guardrail transition. That's our TL3 model. This replaces the bridge connector type A. As you can see here, some pictures of one that's been installed on the Western Kentucky Parkway. So let's look at the new standard drawing, or SEPIA, for this one. Right here in the general notes is a biggie, and it was a biggie for the bridge connector type A as well. But concrete curb shall be standard header curb or standard header curb and gutter as shown. This curb is required as part of the THRIE beam connection. And right here, all costs are incidental to the lump sum bid price for THRIE beam guardrail transition. That is required if you have a curb box, a flume, or not. So that curb is there. Some of the biggest, that's a common item we see on final inspections, because that's a roadway item, and the might have a bridge contractor and just not communicating back and forth, not sure who's supposed to build that curb. Just make sure it's there. It's designed to be there by the standard drawing. So let's look at the drawing for that curb and the guardrail itself, the THRIE beam leading up to the connection on the bridge. So here you want to make sure you transition your curb to match the barrier profile within the first 4 foot of the curb length. So right here you want to transition all this to match. Next, your curb height here at the base needs to be 4 inches. That's great for snag height. If that does deflect, you don't want your concrete curb snagging something under the car. Then up here you've got 5 spaces, a 7-foot long post, and it says see General Note 3. General Note 3 says these all need to be marked and shall be located within the top foot region of the post. It's a 5/8 inch in height and visible. Steel post shall be marked with a stencil before galvanizing. So make sure those are marked as per this standard drawing. There is a final product of one installed. Here, notice you don't have a flume or a curb box. This is just the shorter rail that is required regardless, and see how they've got the taper down to less than 4 inches at that end. All right, so the TL2 transition, it's a little bit shorter, but it still has its own detail. This is Sepia 56. So let's look right here at this general note that's circled. This general note says this railing has been successfully evaluated to meet TL2 criteria when speeds of 40 miles an hour or less. But right here, install a 12.5 foot of standard header curb or standard header curb and gutter if a curb box inlet type B or flume is required at the end of the bridge. See the standard drawing, all costs are incidental to the THRIE beam guardrail. No curb is required if a flume or curb box is not installed at the end of the bridge. That's a biggie. This one is only required if you have a drainage system at the end of the bridge. If there is none, the connection itself is so short it does not need the curb. So if you have a TL2 THRIE beam connector, curb is not required if you don't have drainage at the end of the bridge. So let's look here again at the connection. As you can see, it is a shorter section than it was for the TL3. See that there? Right here is that same note where it says install the curb if the flume or the curb box is required. So note that if you've got these short TL2 sections, you don't need a curb if you don't have a flume or curb box. All right, so let's review the different types of bridge rail that we've talked about. You got the railing system type 2 that's got the box beam on the back side, the strong post. The SEPIA 54, the side mount MGS rail. It's got the square tube that the weak post fits in. Make sure the bolting is right. Make sure your posts are spaced correctly. You got your top mount, SEPIA 55. It is TL3. You got to have a 7-inch deck or greater. So these are 8-inch decks. They have to be formed holes. Unless you're doing a slab bridge, then they can just cast them in. And then our single slope wall, 40 and 36 inch. So let's look at our types of bridge rail connectors. Our TL3 connector, THRIE beam, is our longer section. The TL2 is a shorter section. Remember, on the TL3 THRIE beam, curb is required regardless. But on the TL2 THRIE beam, it is only required if you have a flume or curb box at the end of the bridge. And then finally, we do have some MGS guardrail that leads up to it. If you look at our railing system type 2, our SEPIA 54 and SEPIA 55, remember those that said you got to have 25 foot of anchorage at the end of the bridge. So make sure you've got that 25 foot at each corner. All right, that is it for this section on bridge rail and rail connectors for structures. I hope you've enjoyed this video. I hope to see you in class one day. If you have any questions or comments, leave them in the comments below. Give me a like and subscribe to this page.